Very warm good afternoon to all. This is Maria Pushpam, and we are going to see for today's class two topics. The first one is degrees of freedom, and the second one is principle of equipartition of energy. So these are the two titles we are going to see for today's class. So I'll start with degrees of freedom. So what I mean by degrees of freedom is when energy is supplied to atoms and molecules, it undergoes three kinds of motion. I'll repeat. So when you supply energy to atoms or molecules, three kinds of motions will be developed. Okay, it undergoes three kinds of motions. The energy supplied to atom or molecule, the atom or molecule will undergo three kinds of motion, movement, and this we call it as degrees of freedom. This we call it as degrees of freedom. I'll say what are the degrees of freedom: translation degree of freedom, rotational degree of freedom, and vibrational degree of freedom. So these are the three degrees of freedom. புரியுதா என்ன சொல்கிறேன்னு? ஸோ டிகிரிஸ் ஆஃப் ஃப்ரீடம்னா என்னென்னா, ஆட்டம்க்கோ மாலிகுல்க்கோ நம்ம வந்து எனர்ஜி கொடுக்கும்போது அது என்ன பண்ணுன்னா, இட் டென்ஸ் டு மூவ். ஸோ அது மூவ் ஆகிற அந்த மோஷனை வி கால் இட் இஸ் டிகிரிஸ் ஆஃப் ஃப்ரீடம். இட் டென்ஸ் டு மூவ் இன் த்ரீ டிஃப்ரெண்ட் ways, and the three different motions are said to be translation degree of freedom, rotational degree of freedom, and vibrational degree of freedom. So we can see one by one. First I'll say what is said to be translational degree of freedom. So what I mean by translation degree of freedom is it represents the movement of atoms and molecules along the three Cartesian axes. So this degree of freedom we call it as translation degree of freedom. So if you give a molecule energy, it moves in translation degree of freedom in three axes: x axis, y axis, as well as z axis. So in all the three ways it is moving. So if you take any molecule, it has three translation degrees of freedom. So F trans is equal to 3 for all sort of molecules. Okay. So I'll go with the next one. So next one we call it as rotational degree of freedom. Rotational degree of freedom. It is represented as F rot. Okay. A linear molecule lying along the x axis will undergo rotation perpendicular to the other two axes. That is, if you take a linear molecule, you are applying energy, and the rotational degree of freedom, how does it rotates is, if it is in the x axis, it rotates in the y direction, also in the z direction. It rotates in two axes. Thus, two rotational degrees of freedom will be there. Therefore, linear molecule. புரிஞ்சுதா என்ன சொல்கிறேன்னு? ஸோ ரொட்டேஷன் டிகிரி ஆஃப் ஃப்ரீடம் பார்த்தீங்கன்னா லீனியர் மாலிகுலுக்கு ரெண்டெண்ணா இருக்கும். ஏன் ரெண்டு இருக்குன்னா, அது எக்ஸ் ஆக்சிஸில் இருந்துச்சுன்னா ஒய்லையும் இசட்லையும் ரொட்டேட் ஆகும், ஒயில் இருந்துச்சுன்னா எக்ஸ்லையும் இசட்லையும் ரொட்டேட் ஆகும், இசட்ல இருந்துச்சுன்னா எக்ஸ்லையும் ஒய்லையும் ரொட்டேட் ஆகும். இஸ் இட் ஓகே? ஸோ இஃப் யூ டேக் linear molecule, it will have two rotational degrees of freedom. If you take a non-linear molecule, what happens there is it has three Cartesian axes, so that it has three rotational degrees of freedom. If you take a non-linear molecule, linear molecule only we have two rotational degrees of freedom, but if you take a non-linear molecule, it has three rotational degrees of freedom. Is it okay? So I'll go with the next one. So next we call it as vibrational degrees of freedom. Vibrational degrees of freedom. Are you able to understand the first two? So first one is translation degree of freedom. Second one is rotational degree of freedom. So if you take translation degree of freedom, all molecules will have three translation degrees of freedom. And if you take rotational degree of freedom, if it is a linear molecule, it will have two rotational degrees of freedom, and if it is a non-linear molecule, it will have three rotational degrees of freedom. Now I am coming to the vibrational degrees of freedom. It is represented by the symbol F vib, VIB, F VIB. Okay. So coming to vibrational degrees of freedom, the mode of vibration result in the stretching and bending of the molecular bonds. Either it will undergo bending or it will undergo stretching. Okay. The stretching may be symmetric or asymmetric, while bending may be in plane or out plane. So stretch vibration பார்த்தீங்கன்னா two sortsல இருக்கு. One we call it as bending mode, another one we call it as stretching mode. So stretching mode பார்த்தீங்கன்னா symmetric stretching இருக்கும் asymmetric stretching இருக்கும். Bending பார்த்தீங்கன்னா in plane bending, out of plane bending. So these are the two different things in vibrational degrees of freedom. Is it okay? So a polyatomic linear molecule, if you take a polyatomic linear molecule, it will have 3n minus 5 modes of vibration. அதே non-linear எடுத்தீங்கன்னா it is 3n minus 6 modes of vibration. I'll repeat. So if you take a linear molecule, it will have 3n minus 5 modes of vibration. If you take non-linear molecule, it will have 3n minus 6 modes of vibration. So for linear molecule, the formula is 3n minus 5, and non-linear molecule, it is said to be 3n minus 6. Okay. So you have to carefully listen these points, because based on this only I'll explain the problems for you. Is it clear with the thing? So I'll explain the problems based on this. Okay. So have in mind, so coming to vibrational degrees of freedom, if it is a linear molecule, will have 3n minus 5 modes of vibration, and if it is a non-linear molecule, will have 3n minus 6 modes of vibration. Okay. So I'll go with the problem. So coming to monoatomic gas. Monoatomic gas means it will said to have only one atom, helium. Example. So if you take translation degree of freedom, it will have F trans is equal to 3. All will have F trans is equal to 3. And coming to rotation, it is said to have only one atom. It is said to have only one atom. So what you can say here is there won't be any rotation. It won't rotate. Only one atom is there. Nothing to rotate there. So F rotational is equal to 0. And coming to F vibration also, since it is a monoatomic molecule, F vibration is also equal to 0. Is it okay? So coming to the next point, so diatomic molecule, so F trans is equal to 3, and F rotational is equal to only, it is in one axis, it will be only in one axis, linear molecule. Okay. So F rotational will be 2, and F vibration will be equal to 1. F vibration is equal to 1. It is a diatomic molecule. So F vibration will be equal to 1. Okay. So coming to linear triatomic molecule, we are taking into consideration polyatomic molecule. So if it is a linear triatomic molecule, example carbon dioxide, translation as usual, F trans is equal to 3. And if you take F rotational is equal to 2. Why we say it is 2 means, for rotational linear molecule it is 2. Non-linear means it is 3. So see, since it is a linear molecule, F rotational is equal to 2. And coming to F vibrational, since it is a linear molecule, the formula is 3n minus 5. Can you understand me? Vibrational formula என்னது linear molecule. அப்போ 3n minus 5. எவ்வளவு atoms இருக்கு? 3 atom இருக்கு. So 3 into 3. n is equal to 3. 3 atom இருக்குல்ல? So n is equal to 3. So 3 into 3 is nothing but 9. 9 minus 5. F vibration is equal to 4 for linear triatomic gas. Coming to non-linear triatomic gas, water molecule is an example. F trans is equal to 3, F rotational is equal to 3, because it is a non-linear molecule, rotational is also 3. Okay. And coming to vibration, we have 3 atoms, but it is said to be a non-linear molecule. So the formula is 3n minus 6. So 3 into n is 3 atoms, 2 hydrogen, 1 oxygen. So the 9 minus 6, the answer is said to be 3. Is it clear? So I have explained you the example form, how to calculate this degrees of freedom. The example we have taken is helium, hydrogen, carbon dioxide as well as water. Helium is a monatomic molecule, hydrogen is a diatomic molecule, and carbon dioxide is a linear triatomic molecule. Water is a non-linear triatomic molecule. I think you are able to understand what I am saying here. And next topic for this class, what we are going to see is principle of equipartition of energy. Principle of equipartition of energy. Equipartition means it is nothing but equal amount of energy is given by all atoms or molecules. Okay. So principle of equipartition of energy. The total energy of a system is distributed equally among the various degrees of freedom, equal to half kT per molecule. I'll repeat. It is said to be half RT per mole. Mole எடுத்தீங்கன்னா, if you take a mole, what you can say is half RT, and if you take a molecule, it is half KT per molecule. Is it okay? So this is something about equipartition of energy. So what do you mean by equipartition of energy? It's the total energy of a system which is equally distributed among the various degrees of freedom, and the value is equal to half. You can say it is half KT, or you can say it is half RT. Half KT, or you can say it is half RT. Is it okay? You are clear with the point here? So equipartition energy is nothing but it's a total energy of a system which is distributed equally among the various degrees of freedom, equal to half KT per mole or half KRT per if it is a molecule, half KT, mole means half RT. So this principle we call it as equipartition principle. So we can calculate the values. So we can say one by one, the degrees of freedom we can see one by one. So E total will be equal to E translation energy plus E rotational energy plus E vibrational energy. So E total is equal to, total energy will be equal to E translation energy plus E rotational energy plus E vibrational energy. So so we can calculate one by one. So first we can see what is the energy given by translation degree of freedom. So each translation degree of freedom contributes half RT to the total energy. So நீங்கள் translation energy பார்த்தீங்கன்னா அது வந்து whole systemக்கு எவ்வளவு contribute பண்ணணும்னா half RT. So E trans is equal to, it's nothing but is equal to F trans half RT, F trans half RT. So coming to rotational in degrees of freedom, it contributes half RT to the total energy. So you can write it as E total is equal to E rotational energy is equal to F rotational into half RT. And coming to vibrational degrees of freedom, it contributes RT to the total energy. Why we say it is RT? There are two forms of vibrational energy. One we call it as kinetic energy, another one is said to be potential energy. So kinetic energy will contribute half RT plus potential energy will contribute another half RT. So half RT plus half RT, the answer is said to be RT. Is it clear now? So this is the total energy contributed by translation energy, rotational energy as well as vibrational energy. It's clear now? So energy, the amount of energy given by us, supported by the different energies, is given by degrees of freedom, which is nothing but E trans is equal to F trans into half RT. If it is E rotational, it will give F trans into F rotational into half RT. If it is vibrational energy, E vibration will be equal to F vibrational into RT. So this is the energy contribution. So using this we can find the energy from equipartition principle. We can calculate the energy given by the different energies to the total energy of the system. Okay. So first, is it clear now? Should I repeat? Anyhow, I will repeat once again. So E translation energy will be equal to F translational into half RT. E rotational will be equal to F rotational into half RT, and E vibration will be equal to F vibrational into RT. And the reason for this RT is nothing but two sorts of vibrational energy are there. One is kinetic energy, another one is potential energy. So kinetic energy will give half RT and the potential energy will give you half RT. So half RT plus half RT, which is nothing but equal to 1 RT, which can be written as RT. Is it okay? So we can go with the problems. Okay, ma. Calculation of energy from equipartition principle. So first we can calculate for helium. Helium and the thing is given as 300. Why we have written as 300 is nothing but degrees of freedom. ஹீலியத்துக்கு பார்த்தீங்கன்னா நம்ம என்ன பண்ணோம்னா ஹீலியம் 300. ஏன் 300 போட்டிருக்கோன்னா first is given by translation energy, then the second one is rotational energy, and last one is vibrational energy. நம்ம பார்த்தோம், ஏற்கனவே பார்த்துட்டோம். ஹீலியத்துக்கு the value translation பார்த்தீங்கன்னா 3 degrees of freedom இருந்துச்சு. rotational பார்த்தீங்கன்னா 0, vibrational energy பார்த்தீங்கன்னாலும் 0. ஸோ 300. எனர்ஜியோட வேல்யூ நம்ம ஏற்கனவே பார்த்துட்டோம். E is equal to 3 into translation எவ்வளோ சப்போர்ட் பண்ணும், half RT. So 3 into half RT plus 0 plus 0. So the total energy given by helium is nothing but the total energy of helium atom is 3 by 2 RT. Then coming to hydrogen. Hydrogen we are writing as 3, 2, 1. இது நம்ம ஏற்கனவே பார்த்துட்டோம். degrees of freedom அதுக்கு வந்து translation 3, rotational 2, vibration 1 answer. So 3 into half RT plus 2 into half RT plus 1 into RT. இது முதல்ல half RT எதுக்கு போட்டிருக்கோன்னா it is meant for translational energy. அடுத்து vibrational energy, second one is vibrational energy, rotational energy, and third one RT is meant for vibrational energy. ஸோ உனக்கு மொத்த ஆன்சர் எவ்வளோ வரும், 3 by 2 RT plus RT plus RT. So the final answer will be equal to 7 by 2 RT. 7 by 2 RT. And the third problem is for carbon dioxide. The value is 324. 324. Appo energy will be 3 into half RT plus 2 into half RT plus 4 into RT. And the answer is 13 by 2 RT. And coming to water, it is 333. So 3 into half RT plus 2 into half RT plus 3 into RT. So the final answer is nothing but 6 RT. Is it okay? So I'll repeat this equipartition energy calculation once again. So helium எப்படி எழுதுவோம்னா helium is equal to 300. ஏன் 300 ன்னு சொல்லிட்டேன், you can understand the reason. So the energy answer நம்ம equipartition energy கண்டுபிடிக்க சொன்னாங்கன்னா it's nothing but E is equal to 3 by 2 RT. And coming to hydrogen, it is 7 by 2 RT. Carbon dioxide, it is 13 by 2 RT. Hydrogen, it is 6 RT. You can understand. If you have any doubts, you can call me and ask me. Okay. So we can have a recap of the thing what we have seen for today's class. So first we have seen something about degrees of freedom. So degrees of freedom எப்படி வரும்னா it's nothing but when you supply energy for a system என்ன ஆகும்னா the molecule will move, and this motion is called this degrees of freedom. There are 3 degrees of freedom: translation, vibration, as well as rotation. Okay. So I have said you for all molecules will have 3 translation degrees of freedom, and coming to rotational, linear molecule will have 2 rotational, non-linear will have 3 rotational degrees of freedom. And coming to vibrational, there are 2 modes. One is linear molecule, it is 3n minus 5, and if it is a non-linear molecule, it is 3n minus 6. And the second topic we have seen for today's class is equipartition principle. And coming to this equipartition principle, using this we can calculate the energy, total energy afforded by the system by different atoms or molecules. So E total will be equal to E trans plus E rotational plus E vibration, and the value of E trans is nothing but F trans into half RT. E rotational is nothing but F rotational into half RT. E vibration is equal to F vibration into RT. Is it okay? So I think you are able to understand what I have taken today. Thank you for listening. Keep on studying. Thank you.